more people coming in, but I'm going to go ahead and get started on the little Wildfire Commons update part. For everyone joining, we recently, last week, were able to launch Wildfire Commons on the July 31st. And we had a great interest from the community. Thanks you all so much for that. And since then, we've been running office hours, and we've seen a lot of interest in different features. So we wanted to quickly, before the webinar, also overview what Wildfire Commons is. As you know, it's a new initiative to enable collaboration and also accelerate use of science and technology within fire tech. So it's really to create this cross-sector collaboration and integration through integration of community through an expert network tool. So you can actually introduce yourselves, register yourselves through the platform as experts, and through an enabling platform called FireForge to catalog, access, and explore datasets, models, tools, and other things that could be enabling building blocks for fire tech. And then coming soon in December, to create a community marketplace that helps with both collaboration, but also scale and sustainment of these type of science and technology-driven fire tech building blocks and the fire tech itself. And also maybe create an environment of new developments towards new innovation models in this space. So if you would like to start participating in any of these, you can join the expert network tool. You can log into Wildfire Commons. You can create a profile. You can start using the FireForge. You can sign up for office hours, and if you'd like to bring in new data sets, models, services, you can definitely learn about how to start providing those. We have case studies. One, we have been ongoing 4D fire fuel smoke models case study. And the next one is going to start in November on the foundations for digital twins in the wildland fire space. So you can join those case studies and join the community workshops and meetings there. And you can also submit a Pathfinder project. So if you have an initiative that you'd like to see multiply the impact of through the commons, definitely it could be suggested as a Pathfinder, and we can work with you to bring that to the platform. And the last bit is there are 4 working groups. More will be announced over the next year. You can participate in working groups, or you can suggest new working groups that would benefit the community at large. And that is on Wildfire Commons. But today, hope to see you join us there. Today, we have a great webinar by Danielle Golon on USGS EROS. And as most of you might know, EROS is home to one of the largest archives of remote sensing data. Almost 90 years of data sets available on satellite and aerial data. And I think there is a great way to serve this to the community and lots of interesting applications. I'm looking forward to hearing about those. With that, I would like to pass it on to Danielle. And at the end of the webinar, we'll be taking questions. So please take questions until then. Thank you.
Perfect. Thank you very much. And can you all see my screen okay? Just wanted to confirm. Perfect. Yes. And I'm going to stop my video, but just wanted to say hello, but I'll turn my video off so you can focus on the screen. All right. So hello. Thank you all for joining us today and giving me a chance to talk about some of the cool data, tools, and services we offer from the USGS EROS. My name is Danielle Golon, and I'm the Remote Sensing User Services Lead here at the USGS EROS. And I'm in a pretty unique position where I get to work directly with our users and a lot of the staff from several of the different projects here at EROS, the Earth Resources Observation and Science Center. It's located in Sioux Falls, South Dakota. But for this presentation, I'm going to provide information on some of the wildfire-related products from those projects and tools to access the data, as well as a few demos of some select tools. Since I have a short amount of time and a lot of information to cover, I did want to know I'm not planning on going super in depth into any of these subjects. So definitely consider this a Cliff Notes version to EROS. Now on screen, I've included a ton of links throughout the presentation. So I highly recommend visiting links to the various websites listed throughout to explore different data sets, as there may even be some that I don't mention today that could be great for your work. And I also want to make sure I have time for all the demos. So there are going to be some information on slides that I won't verbally mention, but since the slides will be distributed, please make sure to check out the links on the slides to learn more. And I fully recognize I'm talking to a room of experts now. So I'm most likely going to cover things in a very simplified way that a lot of you already know about. So I will apologize for that in advance. But what I'm hoping today is that I'll introduce you to a few new data sets or tools that'll help you with your work in the future. All that is to say is if there's something I mentioned today that piques your interest, please visit the links and please feel free to ask about it in the chat or reach out to the custserve@usgs.gov email address. This is the email address for my team. We'll be able to help you to answer your questions there or direct you to someone at EROS that will be able to help you. So with that, we'll go ahead and get started. The USGS EROS is home to one of the largest civilian archives of geospatial data. We archive and ingest a wide variety of data, ranging from our aerial photography to satellite data and more. And I've included some of the data sets on screen that are more often used in wildfire studies and response on these slides. Now there's three that I'd like to note. Our aerial photography images. We have over 5.2 million aerial images with data that spans from 1937 to 2023, and include a lot of different data sets primarily over the United States. This image on the right shows our first aerial image we have over California in our collection. It's from November 14th, 1940, near Fresno, California. So for reference, it's pretty close to Sequoia and Kings Canyons National Parks. Now I'm mentioning this data set because we've had users that write in specifically looking for data to observe patterns and trends of what an area looked like before a historical fire, so they can go back and compare it to what the area looks like today. So having an archive that goes all the way back to the 1930s has been tremendously helpful on that front. Another data set I'll mention, and that's simply because I think it's relevant to some of the members of this group, we have the commercial satellite data. This is such as GeoEye-1, QuickBird, Worldview, and these are available to users that are affiliated with a government agency at no cost to those users. So if you or any of your colleagues are affiliated with a government agency, these data sets are definitely something to look into. And I do want to recognize, I know these are not open data, and most of what I'm going to talk about is open data, but I did want to mention them just in case anyone on the call is affiliated with a government agency and was not aware that these were available to them. The third is a newer effort here at EROS, which is our near real-time burn severity maps. We've been working on these maps to support the Burned Area Emergency Response Team managed by the U.S. Forest Service and Department of Interior agencies. This project expands the availability of these data for additional post-fire landscapes to support post-fire stabilization and rehabilitation activities of local, state, tribal, and non-land management federal agencies. In addition to archiving the data, we also make these data available to the public. On screen, I'll highlight some of our more popular tools and note a few that you might most be interested in. So first, to access any of the data from the USGS EROS, you will need an ERS account or an EROS registration system account. It is free to create, but it is required for most of the data. We also have our Earth Explorer tool, or EE. This is easily our most popular tool. EE provides users with the ability to search and order geospatial data from EROS. It also provides the ability to subscribe to data to be notified of when new data are over your study area when those new data are added to the archive. So if you are monitoring a fire or recovery from a wildfire, you can enter in your area of interest into Earth data or into Earth Explorer. and be able to set up a subscription to be notified maybe when new Landsat data is over your area. Now, the image on the right shows an example of Earth Explorer in which I've searched for Landsat data over Los Angeles area during the wildfires on January 14th, 2025. The imagery is shown using the band combination 654. It's a false color vegetation analysis band ratio, which really highlights where some of those fires occurred. We also have our Hazard Data Distribution System, or HDDS Explorer, and the Collection Management Tool, or CMT, which provides a collection of imagery and documents designed to assist in disaster response. This is in an effort tied to our emergency operations here at EROS. The CMT tool allows users to view events being supported through the emergency response system. You can see new area of interest, or AOIs, that have been submitted for a specific event and/or monitor the collection progress for previously submitted AOIs. Once data are collected, they are available in the HDDS Explorer, as well as imagery of the same region before the event. So a very helpful tool for quickly finding data related to a specific disaster. And I'll be providing a brief demo of the HDDS Explorer next, but I did also want to mention that we have the machine-to-machine, or API, machine-to-machine API, which provides access to data programmatically for any users looking for an API. So this brings us to the first demo of the day, the HDDS Explorer. Now, as I mentioned, the USGS provides access to remotely sensed imagery and geospatial data sets in response to requests from agencies engaged in disaster response. One agency or group will submit an initial request for support. Once the imagery is captured, it's available on the HDDS Explorer, and it can be shared across the response community. Now, for this demo, I'll be showing you how to find fire-related data within the tool. And for the sake of time, these demos are really going to cover main features of these tools. If you would like a more in-depth information on the tool, be sure to check out the help documentation I've listed on each slide. And you can also contact the email that I've listed for each slide for the tool as well. And we'd be happy to fully walk you through the tool and all the different features at a later date. Just for today, I'm going to cover more of the main features. So with that, I'll transition over to the tool and we'll start the demo. Okay, so the first step for the HDDS Explorer is, as I mentioned, you'll need to create an ERS account if you do not already have one. I went ahead and already logged in with my account just for the sake of time, but you'll go to hddsexplorer.usgs.gov, and then we'll go to the search criteria. So here is where we're going to filter down for our AOI and our date range. So if you have a shapefile of your area of interest, you can upload that. Otherwise, you can also interact and click on the map. So I'm going to use my mouse to kind of roll the wheel, and I'm going to scroll into the area around California. I'm going to update the layer to show the national map layer just for right now so I can see the boundaries of California. And I'm going to go ahead and draw a polygon around California. I'm just going to briefly do this quickly. Obviously, if you're using the tool, you might want to pick a more specific location and not draw just a general outline. But for today, the general outline will work. So I'm just clicking on the map to add my dots and my points to complete my polygon. So here I can see I've got the shape of California outlined. And let's say we're just interested in fire events that have occurred this year. So I'm going to go ahead and click on my map, and I'm going to go to January 1st. So I'm just clicking on the month, clicking on the date, and then I'm going to go ahead and click on the yellow one is today. So I just want to see all the most recent data. So I'll go ahead and click on August 15th. And then I can go ahead and click on my events. Now this is going to show me all of the events that are in the HDDS Explorer. Obviously, there's more than just what's in 2025. It goes all the way back to 2004. So if I want, I can start exploring these events. I can also use the event search. So I can type in fire and I can see all the events in the HDDS Explorer that are related to fire. But if I'm interested in just my study area, I'm going to go ahead and use this event pre-filter. And that's going to trim that down just to the events in my time period over my area of interest. So I'm going to go ahead and click on this 2025 and open up the option. And then I can see there was a landslide, but I'm interested in this fire data. So we have 2025-01 fire. If I click toggle coverage map, I can see what the area of interest was submitted for this data. If that looks good to me because it covers in part of my study area, I'm going to go ahead and check the data set, saying that that's the event I'm interested in. Now, if you want to filter down even further by metadata, or maybe you only want a specific sensor, you can use the additional criteria. For today, I'm interested in all of the data that I have from this event. So I'm going to go ahead and click on results. And this is going to search for the fire data. Now, the interesting thing here is that I have all this data now. So I have Landsat 9, Landsat 8, Worldview 3, a couple other different data sets. But what I'm mostly interested in is now looking at what these icon buttons do. So if I click on the foot, it'll show the footprints on the map. So I can see as I'm clicking it, it's adding the footprints to the map. So I can add a couple of different footprints. Oh, it looks like I apologize. I missed part of California down here. So I do have some of the data for California. So I'm going to zoom in and I can see that this is some of the data over San Diego, kind of near Los Angeles. So this might be one of the data sets that I'm interested in exploring. So I can go ahead and do show browse overlay, and that's actually going to add the image to my map. So I can kind of start to see and preview what that imagery will look like. If that's something that I'm interested in, I can also click on show metadata and browse, and that'll show me all of the metadata information. Now, this is also a really great option. If you open in a new window, it'll show me a full display and all the metadata information. But why I particularly like this feature is I can send this link to someone else. They'll be able to see this scene right away. If they're interested, they can scroll all the way to the bottom, log in with their ERS account, and then click on the download button and start downloading the data right away. Now, if you are interested in downloading a lot of the data, maybe, let's see, we have 1,031 scenes over this event. I can go to the show results control and I can add all of the current ones. So it'll be 100 scenes to a bulk download order. I could also use this add to bulk download button. It's a box with a little down arrow. I can click on all of these to add that. So if I want to bulk download, I can download a lot of data. It'll generate a list that I'll use in our bulk web application tool, which I have a link on the slide linking you to that tool, as well as a previous webinar for how to use that tool. If you're interested, let's say, in maybe just a handful of scenes, you can click on this shopping cart to order the scenes. But today I might just be interested in exploring this one scene. You can go ahead and click on the download options button. And this will bring up the options to download either the full resolution data, medium quality JPEG of the data, low quality JPEG of the data, or metadata for this image. Once I click on any of these, it'll immediately start downloading to my computer, and then I can go off and work with the data. And I did want to note, I'm not going to show Earth Explorer today, but if you already work with Earth Explorer, or if you haven't before, the HGDS Explorer almost looks like a carbon copy of Earth Explorer. The functionality is very similar. These buttons are the same. The search criteria is the same. The main difference is instead of picking events, you would just pick the satellite sensors or aerial imagery or other data sets that you're interested in. But it works pretty much essentially the same. All right, I'm going to shift back into the presentation. So that covers some of our more general EROS data and tools. From here, I'll start diving into some of our specific data sets and projects here at EROS. So first, we have Landsat. As a quick background, the Landsat program consists of a series of Earth-observing satellite missions jointly managed by the USGS and NASA. The first satellite, Landsat 1, was launched in 1972, and the most recent satellite, Landsat 9, was launched in 2021, providing over 50 years of data. Be sure to visit the Landsat website, which has a lot of information about the data, how to access and how to use the data, and more. And we also have several types of Landsat data at a spatial resolution of 30 meters, so a lot of which can be pan-sharpened to 15 meters, and they can be used in a variety of ways to observe land use and to document how the land is changing from natural and human causes. Landsat offers a wide variety of tools to access the data, including Earth Explorer, which we just talked about a little bit earlier. So be sure to check out all those different tools. And if you're interested in staying up to date on all things Landsat, we do have the Landsat listserv, and that link will take you to read the listserv messages, and then also a place to sign up for the listserv. Some examples of Landsat data being used to observe wildfires include Landsat 8 real-time data and Landsat 9 data. These are typically acquired 4 to 6 hours after acquisition. Plus, we offer a lot of nighttime imagery over the Western US during the summer, which allows for additional chances of capturing imagery over your AOI. This can be incredibly helpful for monitoring an active wildfire overnight or just getting more data in general of the fire. There are 11 spectral bands allowing users to view the data in a variety of ways. This image shows Landsat 8 data when it captured a fire near Monterey and Big Sur a few hours after the fire started on July 2nd, 2016. And then 8 days later, after it had grown, we can definitely see a lot of smoke in this image. And then it captured another 8 days after that. We can start to see where a lot of the vegetation burned, where some of the active fire was still burning with the smoke. And so that's the true color, that's the 432 band combination. But with the shortwave and near infrared or 754 band combination, we can see where the active fire was in that middle image, as that band combination allows us to penetrate through smoke, and we can see the fire with the orange. So active fires are bright red and orange, scarred land is a dark red, intact vegetation and human development are different shades of green. We also have the Landsat Burned Area Science product, which is designed to identify burned areas across all ecosystems. It contains 2 acquisition-based raster files that represent burn classification and burn probability. Now, the image on the right shows a fire that occurred in Yellowstone National Park back in October of 1988. You can see the burned area data highlights the burned areas from the fire in the GIF. And I've listed some of the potential uses of these data included on the slide, but they range from planning and managing fire occurrences and later on evaluating the fires. Next up, we have our annual NLCD project. They provide a lot of key land cover type data. Please visit their website to learn more. They have 2 different websites, but a lot of great information there as well on these data sets. The main data set available from this team is Annual NLCD, which consists of 6 raster land use and land cover science products for CONUS from 1985 to 2024. They also have a rangeland data set for anyone on the call specifically interested in rangeland data. And then I've listed out on the screen all the different tools that you can use to work with these data. I will note, I had mentioned that for some data sets, you don't necessarily need an ERS account to download the data. That's for the MRLC NLCD viewer, the MRLC range viewer, the EVA tool. Those you'll be able to access as long as you provide a working valid email address. And they also had OGC services they wanted me to point out, as well as Mosaic downloads if you're interested in a lot of the data. And of course, we have the MRLC annual NLCD listserv if you'd like to stay up to date from anything going on with the annual NLCD team. One of the annual NLCD products used in studying wildfires is the land cover change product. It depicts land cover change between one product year and the next. Changes are represented in the latter year. So if you watch on screen, in this area, we'll see where the fire was impacted to show the following year. I'm going to turn off my laser pointer and turn on the image, and we can see where the land cover changed mostly from evergreen forest to primarily grasslands after the fire. Next up, we have our LANDFIRE program. LANDFIRE is a shared interagency wildfire management data program across the US and its territories. The LANDFIRE team is a really great website where you can learn all about the project, their data, their outreach efforts, and more. I see a couple of people are on the call from the team. So it's a really great website to learn more. I'm assuming most of you on the call are familiar with LANDFIRE, but LANDFIRE provides a lot of landscape scale geospatial products of biological and ecological data, as well as vegetation and fire behavior fuel models. LANDFIRE has several tools to work with their data, including the LANDFIRE map viewer, which allows you to download data by product layer for your specific area of interest, which I'll briefly demo in a few minutes. And I've also included specific contact information for contacting the LANDFIRE help desk team. My team will help to answer the questions, but this way you can either submit it on their website or email them directly, as well as a link to the LANDFIRE mailing listserv. Now, LANDFIRE, again, has a plethora of wildfire-specific data. Unlike some of the other groups I'm mentioning today, fire is their main focus, and all of the data sets relate to it in some form. So I highly encourage you to visit their website to learn more about all of the different data sets they offer. But on screen, we're highlighting two of our more popular data sets with wildfire practitioners that they seem to find helpful. The first is the forest canopy cover, or FCC, which shows the percentage of canopy cover. This image is from the LF 2023 dataset when the Smith River complex fire occurred near the border of Northern California. The second image is the US disturbance 2023, which shows the disturbance data from the same year, in which we can clearly see where the disturbance of the fire occurred. So with those two images I just showed, let's see how I found that data with a brief demo of the LANDFIRE map viewer. So we'll be looking at fuel vegetation cover data over California from LANDFIRE LF 2023, and then we'll download it. So with that, I'll move back over to their tool. So as I mentioned, we're going to look at the Smith River complex fire from 2023 using forest canopy cover and US disturbance data in the LANDFIRE map viewer, and then we'll download the data. So the LANDFIRE viewer is the other tool where you don't need to log in with your ERS account. You just need a valid email address that you'll submit at the end to receive the data. So first we'll go to landfire.gov//viewer/. And on the left side is a list of all the data within the tool. So you'll pick your data set of interest. I'm going to go ahead and open the folder for LF 2023, fuel, surface, and canopy. And then I'm going to add the forest canopy cover layer. I'm going to go ahead and turn off this existing vegetation type because whatever layer is on top, that's the layer you're going to see the most. So I'll go ahead and turn that one off. And we can now see the forest canopy cover. I'm also going to turn on the same layer, but from 2022, so we can see maybe what the area looked like prior to the fire. So we do surface canopy, forest canopy cover. And then I'm also going to scroll down and select that disturbance data that I had mentioned. So now I've got my data added, and I can see the top layer on the map. So now I'm going to show you a couple of unique features within this section of the tool so that we can find our data. So the very first thing that I'm interested in is this magnifier. Now you can use your mouse to scroll and move around, but I find this really helpful. For example, I know this fire occurred near Del Norte County, so I'm just going to type that in. Going to type in California, and then I'll go ahead and click on it, and it'll zoom me into the area. One thing that I have found to be helpful is we have an overview map that you can turn on, so that gives you a little bit more of an idea of where you are on the map. Then we also have a couple of different features here. So one feature that I really like is the Identify tool. So I'm going to go ahead and click on that tool, and now I'm going to scroll a little bit closer in the map, and I'm going to click on a portion of the map, and that's going to open up the Identify tool. I'm going to click on another spot, and this is showing me what these different values were. So for the disturbance data, it did identify that in 2023 there was a fire where I've clicked. The LANDFIRE 2022 layer tells me that it's tree cover more than 30%, but less than 40%. And the LANDFIRE 2023 tells me that it's non-forested area. So here I can definitely zoom in a little bit closer, and I can see what the 2023 canopy cover looks like. If I turn off that layer, I can now see it filled back in with what we saw in 2022. So I'm able to easily compare between 2023 and 2022. And if I turn off the 2022 layer, I can see the disturbance, the US disturbance layer underneath. I'm going to zoom out just a little bit more so we can see the full range of the disturbance data. Now, if I've decided, okay, this is data that I'm interested in downloading, I can go ahead and click on the Data Download tool, and I can either draw a rectangle around the fire, or I can use other methods. So it's opened up this Data Download tool option, So I can draw a rectangle, draw a polygon, works the similar way that the other maps and tools I just showed you work. You can click to add your polygon. I can upload a GeoJSON, or they also have these really cool templates where I can click on the template and I can look at different things like, say, the county boundaries. But for today, we're going to do our rectangle, make it a little bigger than I did last time. And so now it's going to retrieve the available products. I can select the projection if I want to change the projection. We'll give it a second here to load. And it's also going to allow me, once it loads, to select the available products. So we'll give it another second here for it to load. There we go. So we can update the projection if you're interested in updating the projection. We have a standardized projection, a localized. You can also select the products that you want. So again, we wanted that LANDFIRE fuel under surface canopy. I'm going to expand this so I can see the layers a little bit better. We wanted that forest canopy cover. And then I'm also going to go ahead and download that disturbance data as well. It's as simple as scrolling and finding the disturbance layer of 2023. And now I can scroll further down. I can see the latitudes, the coordinates for the rectangle, my bounding box, and I can start typing in my email address. So I'm going to type in that custserve@usgs.gov, click on download, and it's going to send me the data straight to my email. I will just have to get a link from there. I can open up a zip folder, and I actually did this earlier today. And here in QGIS, I was able to just plug that data right in and pulled it up right away. So it just plug and play. It trimmed it to my rectangle. If you did a polygon, it would trim it to your polygon, but a really nice handy tool for downloading that data. So that shows the LANDFIRE map viewer, and I'll go back to our presentation. So we also have the LPDAC. NASA's LPDAC is a partnership between the USGS and NASA. The LPDAC processes, archives, and distributes land remote sensing data. And the LPDAC recently moved to a new website. So if you're previously using their old website, please do make sure to check out the new one and provide any feedback, as we just recently moved. So they are looking for feedback to improve the user experience. The LPDAC offers a wide variety of land data products to support ongoing monitoring of the Earth's land dynamics and environmental systems, and they archive and distribute several large missions and sensors. Now, there are two main tools I'd like to point you to access LPDAC data. The first being APPEARS, or the Application for Extracting and Exploring Analysis-Ready Samples. This is a great tool for subsetting, transforming, visualizing, and analyzing geospatial data. And APPEARS will return interactive charts and graphs you can explore prior to downloading any of the data. We frequently hear from users that they really like APPEARS because it trims down significantly on the amount of processing time you have to do for the data. It does a lot of the processing for you. So with that, I'll give a brief demo of APPEARS coming up, but I did also want to mention NASA's Earth Data Search. This is a great tool for accessing, finding, visualizing, and downloading any of NASA Earth science data. There are some data sets that are not available in APPEARS, but they are all available on NASA Earth Data Search. So you can find all those data there. But I did want to also plug one other tool. It's called NASA Worldview. Since I'm thinking some of you on the call are probably interested in seeing close, big images of the browse previews of the data before you're downloading it, and maybe creating graphics or images from those, or a short video, a short GIF, especially for those interested in being able to quickly see if fire or smoke were caught in the imagery or not. If you just need to go yes or no, you can go to NASA Worldview, pull up the data, and be able to see it quite quickly and make quick visualizations of the data. And of course, as with all slides, I've included their email address. Also note, anytime there's a different email address in the slides, it all goes to my team and we filter it out to the corresponding people to help answer the questions. So at the end of the day, the big one to remember is that custserve@usgs.gov. But if you do want to get directly to the teams, you can also use those other email addresses. We're all part of the same group. And we'll get you sorted to the right staff members. And then, of course, we also have the LPDAC listserv if you'd like to stay up to date on all things LPDAC. Now, the LPDAC has a ton of data. At this point, I believe they have over 800 products, a wide range of their data, some of which falls a little outside of the scope of studying wildfires. So on screen, I'm going to call out a few of the data sets that we know are actively used to study and monitor wildfires. Also noting this is not an exhaustive list. Some of the keyword topics that I'll be showing have way more products than what I've included on screen. So do be sure to go visit those links to see the rest of the products. But first, we have our more directly related to fire products, which are the burned area data sets and the thermal anomalies and fire data sets. Now, the burned area product is really cool. It's a monthly burned area data that identifies the date of the burn for a 500-meter grid, and it's broken out in a layer by each day for 30 days. So a really interesting way to observe how the burn scar grew over time. And then thermal anomalies and fire data, I'll show that in the Appears demo coming up, but they're available as a variety of spatial and temporal resolutions and can be used to identify fires and other thermal anomalies such as volcanoes. We also have a relatively new fire product that I wanted to highlight. This is the VIIRS Fire Modified Combustion Efficiency Product, or VJ147IMG. Now, this is SWOF data, so it's not gridded, but testing has found that it can detect 25 to 30% more fires than that are smaller or cooler than some of the other previous VIIRS data. And it has the added benefit of providing daily global pixel level characterizations of MCE for nighttime surface fires. The LPDAC also has products geared more towards vegetation, including ESI, or Evaporative Stress Index data, evapotranspiration, or ET data, and Vegetation Index, or VI data. Now, several of the products listed on this slide are from the EcoStress mission, so I did want to specifically highlight that mission as it's a little different. It's aboard the International Space Station, or ISS, so its coverage varies as it follows the ISS orbit. But all EcoStress data have a 70-meter resolution, and the goal of EcoStress is to measure the temperature of plants to better understand how much water plants need and how they respond to stress. This can help us study things like drought and where there may be a higher risk of a fire. So EcoStress has a lot of great data and has been used to study pre and post wildfires. But speaking of vegetation data that the LPDAC offers, we have seen ESI, ET, and VI data, such as Normalized Difference Vegetation Index, or NDVI data, used by researchers in the past to help estimate fuel load. So definitely some data you might be interested in exploring further. And there's another data set I'd like to highlight, this HLS L30VI. There's also an HLS S30VI. That is harmonized Landsat Sentinel-2 data. So it provides consistent data products from the Operational Land Imager, or OLI, aboard Landsat 8 and 9, and the multispectral instrument MSI aboard Sentinel-2A, 2B, and 2C. The HLS data specifically is derived from Landsat or Sentinel data and combines specific bands of the data to quantify various aspects of vegetation. So a really interesting combined data set. The LPDAC also offers daytime and nighttime LST, or land surface temperature. The key thing to note here is that this is a temperature of the land itself, not the air around it. And this can help observe locations that are at risk of ignition, as higher temperatures will dry out the vegetation or where a fire is actively burning. Now, this image on the right highlights EcoStress LSTE data, and it shows the recent Madre fire in California from last month. One thing I think is really, really cool about this map is that it was actually made by a 16-year-old Californian student as part of the UCLA Cosmo program. So I thought it was really cool that a high school student was able to get their hands on the data and generate this map and learn more about wildfires by using this data. And then, as you can tell in the data, you can observe the higher LST is where the fire is actively burning. As I mentioned, there's a ton of data here. I didn't even touch on their surface reflectance data, aerosol optical data, elevation data. They have some more canopy-specific data. So again, I really encourage you to visit the website to see all the different 800 data sets. And I have my last live demo for the day. This will be a live demonstration of Appears. I'll be ordering fire and vegetation data from MODIS and VIIRS and showing you how I generated these charts and graphs over the recent Madre fire and what those charts mean, and then ultimately how I was able to produce this map on the right from the first day of the fire within a matter of minutes in ArcPro or in QGIS, either one. from the download that I got from Appears. And a big thank you on the team to CAL FIRE. I was able to grab a shape file of the burn perimeter from your website. I think we slightly tweaked it because there was part of a little gap right here that I think Appears was confused about, but we were able to convert it into a GeoJSON, upload it straight to Appears, and we were able to find the data. So with that, I'll transition over to Appears. So first, to know about Appears is if you don't have an Earth data login account, you will need to create one. Now, this is different from an ERS account. The ERS account is for accessing USGS data, and the Earth data login account is for accessing NASA data. Now, both are free to create, but to access data in Appears, you'll need to have that Earth data login account. After you've created your account, you'll go to appears.earthdatacloud.nasa.gov. I went ahead and already logged in just for the sake of time. And so the first thing that we're going to click on is this extract. Now, I did want to point out there's area examples or point examples. They're going to essentially look the same. So you're going to have basically the same form to fill out. The results will be very similar. The area is just if you upload a polygon, you draw a polygon, you draw a rectangle, you upload a shapefile or a GeoJSON, it's going to clip and mosaic the data to your area of interest. The point, it's going to pull points specifically, so coordinates, or you can click on points on the map and it'll pull data from those very specific points. So if you're interested in point data, do check that out. But for today, I'm just going to show off the area sample. So I'm going to go ahead and click on area. And now I see I have three options: start a new request, copy a previous request, or upload a request file. So keep the upload a request file in the back of your mind. But for right now, we'll start a new request. And so here I can go ahead and start filling out the form. So I'm going to enter in the name to identify my sample. So I'm going to type in Madre Fire. I'm going to go ahead and upload that GeoJSON that I mentioned. So I'm just going to drag and drop it right in there. And you can see it's uploading on the map. Now, if I didn't have a GeoJSON or a shapefile, again, I could just click and draw on the map. It works kind of similar to how some of the other tools I showed before work. Now, you might be saying, Danielle, I worked the Madre Fire. That is not the Madre Fire. That is because, as you can see above, it says the shape you selected was too complex to display and was automatically reduced. However, your request will still be processed using all of the points in the file. So it doesn't look like it here, but when we get our final data, it will be clipped and mosaic to the GeoJSON that I uploaded. So now I'm going to start my temporal information. For start date, I know this fire occurred based on your website, on CAL FIRE's website. It started on July 2nd, but I'm going to go ahead and look at maybe the month before. So maybe we'll start on June 1st. And for end date, I'll just go ahead and pick today. Now, if you do know the name of the data set you're interested in, you can type that, like mod13q1, that's our NDVI vegetation data. I'll go ahead and click on the data set and add the layer of interest just by clicking on it. You can also click on this eye to view layer details if you want to learn more about the data. Now, you may be saying, I don't know what those short names are. That is okay as well. The team has also entered in keywords. So you can type in things like vegetation, NDVI, fire, temperature, a couple different other keywords to find the data set. So I'll type in fire. And here I can see I have all the different fire data. So I'm going to go ahead and click on this VNP 14A1. That's our SWAMI NPP VIIRS fire data. It's a daily product. And I'm going to go ahead and add the fire mass. And just for fun, I'm also going to compare this to see what is the MODIS fire data set, because I know that's one of our popular data sets. I'll go ahead and add the fire later from MODIS as well. It's an 8-day composite versus the daily composite. And below that, I can choose my file format. So I can choose either GeoTIFF or NetCDF4. Now, if the data works with it, you'll also be able to select NV, but because these data sets don't, I can't select that one. So for today, I'm going to go ahead and get this data as a GeoTIFF. And then I can also select my projection. So you can keep it in the native projection, or you can reproject it to any of these projections. I'm going to go ahead and pick geographic today. And then I'm going to go ahead and click on submit. And now Appears is going to run. It has submitted my request. I see I have a green banner here that says my request was successfully submitted. So I'll receive an email saying that my request was submitted and a follow-up email once my request is completed. Now, if something was wrong, this would be a red box and I would just need to go and review what I've entered into this form and maybe update it. Typically, people forget to enter in a name. So for today, luckily, it was successfully submitted. So I'm going to go ahead and click on this Explore menu button or the link in my email. But for today, I'll click on Explore. And I already went ahead for the sake of time and ran this request. So I can see, let's see, I ran it a couple of days ago and it took about 3 minutes. And I had another one that took about 5 minutes to run. So we'll see if this one gets done by the end. But now I can click on View the Contents of this request. And here's where I'll see those charts and graphs I was talking about earlier. I have my various layers. So here I have my NDVI, and it's shown in the form of box and whiskers. So here I can hover over it to see my NDVI values. Now remember, this is 16-day data. Let's see if I can zoom in a little bit for you all. This is 16-day data. So this granule started on May 25th, and then this one started on June 10th. So we're not going to see the fire in either of these, but since the fire started on July 2nd, I'm going to start to see it here, which I do see the ever so slightly drop in NDVI values. But when I see the next granule from July 12th, I assume there's going to be a lot of burn from that vegetation. So in the vegetation from the fire, and I can definitely see that where I have a drop in the NDVI data values. Below that, we also have quality statistics. So Appears does a little bit of the work for you to kind of explain what the quality layers you're seeing, what those mean. So in this case, blue means VI produced with good quality. I would definitely expect that in the scenes where we're not having the fire. But the scene where we saw definitely a drop in the NDVI values, we're seeing an orange, which means VI produced, but check other QA. So I would just need to go in and examine the quality information. Now, the interesting thing about Appears is we also have the other layers. So let's go ahead and look at our Mod 14A2, that fire mass. That's an 8-day product. So I can see now I have a bar graph. So I can see blue means non-fire land pixel. So I'm going to keep scrolling until I get to when I would expect to see the Madre fire. And in this case, it is here. So I can see this means fire. There's a value of 9, which stands for fire high confidence. Value of 8, fire nominal confidence, and orange is going to be, let's see, orange is 7, low confidence. And actually I can see, I thought this was kind of interesting. I started to see another fire pop up, and I believe that this might be the Gifford fire that was just in the tail end of the GeoJSON that I uploaded. So without even downloading any piece of data, I can already find 2 different fires in this data set. Now this is 8-day data, so I'm going to also look at that VIIRS data since it's daily, and I can see all of the days that I've uploaded. Now, if I click and drag, I can filter and zoom in a little bit closer to the data sets. And again, since this is daily data, we can identify where there is high confidence, where VIIRS identified high confidence of the fire. Now, if I decide, okay, this is data that I'm really interested in downloading, I just need to click on this drop-down arrow, and I can click on download. You can also go back to that Explore menu and download from there, but I'll go ahead and click on download. And here I can see all the supporting files that I can download. I have my metadata information. I have a granule list, so I know all of the MODIS VIIRS granules that went into this order. I have a README file, instructions and details about the request. I have a JSON file. So this is where I mentioned keep that other section in your mind. So if you're in the field, or if you're working from home, or if you're at one office and your colleagues at another office, you can send them this JSON file. They'll be able to upload it in Appears, run the request. It'll just pre-populate that folder, that file form for them, run it, and they'll be able to see exactly what you're seeing. So it's a really easy way to kind of share those interactive charts and graphs and to share the data. There's also a lot of CSV, statistics for quality layers, lookup values for the quality bits, statistics for the layers, a lot of great CSV information in there. But below that, I have my clips, mosaic, geotiffs to the GeoJSON that I uploaded. So here I can either type in, maybe I just want to see NDVI data for right now. I can filter it down to NDVI, and I can click and I can download. Maybe I only want to download the first 2. I can also do that as well by clicking download and click on download files. Or I know 184 was the start for, I believe, July 2nd. And so I can click on this layer to just download that one piece of data right away. That's what I did earlier, and I was able to drop it into QGIS, and the only thing I needed to do was update the symbology, but I was able instantly to have that map. And then I also pulled it into QArc Pro, and I was able to add some elements. So I think this took me a matter of minutes just to create this map that I was able to share and add to the slides. So Appears really has some great information and makes it just so much easier to trim down those data. And I did want to mention up here, Appears is also available as an API. So if you are an API user, you can read the API documentation, as well as see a list of available products, change logs to Appears, all that great stuff. Okay, with that, I know we're running a little low on time, so I've also included a few slides at the end of the slide decks with updates from each project. So if you're already working with data sets that I've mentioned, or if you're interested in working with some of the data sets, do be sure to read those slides when they're distributed, as they will have links to GitHubs with e-learning resources, updates on data timelines for some various missions, some new resources for some of our newer data, such as the annual NLCD data set. But with that, I'd like to finish the presentation with again providing our contact information. I know I've said this a couple of times, but we are definitely here to help. So feel free to give us a call, write in, and we're happy to help out as much as we can or find people that can help you answer your questions. I do have two more listservs to plug. The EROS user group listserv. This is where we announce a lot of different things related to EROS data and tools, such as major releases, upcoming webinars, and more. And then we also have the EROS Center headlines mailing list. This has more local news from EROS. So two really nice listservs to sign up for there. And if you are on social media, please feel free to give the EROS, USGS EROS and USGS Landsat program accounts a follow. They're sharing a lot of great information out, showing all sorts of different data sets from EROS. But with that, I'll take any questions.
Thank you for that wonderful presentation, Danielle. We have the Q&A open, but feel free to use the raise hands feature or the chat to also ask questions. I'll be happy to read it for you.
And I don't see the Q&A, so I don't know if Ilya, if there's any in there that you could read to me.
Yes, I have been trying. Just as a quick announcement, Claire had to be out of the office today, so I'm running the telecom. Looks like somehow I'm not able to.
I found the
Q&A.
I found the Q&A, but I don't see any questions in there just yet.
Yeah, I enabled it for posting questions, but I think we can also use the voice feature. If anybody would like to ask questions, please raise your hands or unmute.
And I know I went through a lot of that very quickly, so if there's anyone, if you'd like me to go back to a slide or anything, please just let me know. And we have a few other members from EROS on the call too that have offered to help answer any questions I might not know the answer to.
This is Pam. Just one question. Does the USGS archive include airborne data sets like master and AVERIS and those things? I know they have their own sites. But...
That is a good question. Let me pull up the website that has all of the data sets. 1 second. So we have a wide variety of data sets. I don't believe we distribute AVERIS anymore, but I could be wrong. But this would have all of the data sets spelled out that are available from the EROS archive.
Okay, fair. Thank you.
Mm-hmm. And I can add that to the chat as well. But these will also definitely be distributed, and that link is on the slides.
Perfect.
Mm-hmm.
We'll also share this link with the recording.
Mm-hmm. Perfect.
Any other questions? We have a couple minutes here, and we'll hope to integrate with EROS a lot more seamlessly within the FireForge platform over the next couple of months. we are looking forward to that type of integration with the rest of the applications of the way that some of the data can enable. Danielle, is there any, you provided some links to reach you. Is there any other thing you'd like to share with the group in terms of if they need to follow up? We have couple minutes here. I
don't think I have anything else to include, but I did have a few members on the call. So if anyone from the team had anything they wanted to cover that I did not mention, please feel free to unmute and speak up. Otherwise, I can also show some of the different slides that we have for some of the tool highlights, since we do have a few minutes. So we have for those interested in working with the machine-to-machine API, if you're not sure how to get started, we've started creating new tutorials and guides for working with that API specifically. And we also have a new webinar series called the EROS User Experience Webinar Series. Here we have recordings. So the BDWA, that's our bulk download web application, and Earth Explorer, we have webinar recordings where we've walked through those tools specifically, as well as a quick guide video for that BDWA. For Landsat, we definitely have some resources on their GitHub. I think that's how this group found us for working with Landsat data in the cloud. So introduction to Landsat stack, querying Landsat stack with PyStack, decoding and using Landsat pixel QA bands for masking, mosaicing, and clipping Landsat cogs, and more. We also are considering what Landsat Collection 3 might look like. So if you have any feedback on the topic, please feel free to email landsat@usgs.gov or that custserve@usgs.gov email. Mention in the subject line Wildfire Science Technology Commons with your feedback, just so we know who we're getting it from. We have kind of context of where it came from, but your feedback could help shape future collections. So if there's something you're really interested in seeing, or if you've always wondered, like, why did Landsat do this when clearly they should have done that? That's a great time to share those details. For the annual NLCD, as I mentioned, that was recently released. Version 1.1 was just released last month, and the bigger data set was released back last October. So we have a ton of links for information on product layers, user guides, reference and validation information, some podcast episodes talking about the data, all sorts of great information. And then for the LANDFIRE team, they did want me to mention that they have the LANDFIRE team's moved to providing annual updates. So the next update for the CONUS final annual disturbance product is coming at the end of August, August 28th. All other product updates are coming in early October. And another really cool thing about LANDFIRE is they have monthly open office hour sessions where some of the staff on the call will also stick around at the end of the monthly open office hour section. So if you have any questions about LANDFIRE, you can always attend those webinars. And I've included a link to register just to be notified of when next ones are coming out. But they'll help answer any questions during the open office hour session after the presentation. And the last two that I have, the LPDAC has a GitHub that has a new guide on how to find and access LPDAC data. They also have a ton of scripts, tutorials, and guides for working with all sorts of different data sets and tools, including Appears, EcoStress, EMIT, JEDI, HLS, a few different data sets I've mentioned during this talk. And there's also a new Earth Data Forum. This was started a couple of years ago, but it's really gained some traction. So it's a messaging board where you can write in and either ask questions of staff or just have some great data conversations with other users of NASA Earth data. And the LPDAC had a few more slides, or one more slide. So the LPDAC data are all moving to the Earth Data Cloud. Most of the new data sets are now directly ingested into the Earth Data Cloud. So if anyone on the call has been using the LPDAC data pool in the past, as new collections or their versions are moved to the cloud, they'll be retired from the LPDAC data pool. And eventually that service will be retired once that effort's complete. We're expecting towards the end of the year or early next year. That time is still dependent on how things go, but that's kind of the plan for now. So if you do have scripts accessing the LPDAC data pool, now is the time to update those scripts. And also MODIS is approaching its end of mission. So the historical record will remain. There will be a version 7, but now it really is the time to start examining and transitioning to other sources of data for an easier transition once the MODIS forward processing is no longer available. Now, there's not a definitive date on that just yet, but we do know that it is coming. So we just want to prepare people ahead. And that's why in the Appears example, I showed the MODIS and the VIIRS data. We have 400 VIIRS products compared to the 175 MODIS land data. So a lot of different data sets to explore to see if they'll meet your needs. And with that, there's also a data set I didn't really touch on called ASTER, but it's also approaching the end of mission as well. And I know that's tasked, so a lot of times for natural disasters. So there will be a final ASTER version 4, and that will be available for the whole collection. The historical collection will remain in the archive. And a nice benefit is that ASTER version 4 data will not be require on-demand processing. Currently, for ASTER version 3, for some of the data sets, you do need to do an on-demand processing, but version 4 will just be available for download. So that's the extra slides that I had. Are there any other questions at the end?
I think it's a testament that EROS data is sort of endless. And we'd like to thank you also and the team here on the call for all your work. It's impacted all of our work here. And we hope in the Wildfire Commons that we can bridge that also to the rest of the community. So thank you again, Danielle, and everyone on the call. This slide deck and the whole webinar will be posted at the Wildfire Commons over the next couple of days.
Perfect. Excellent.
We'll share it also on LinkedIn. Thank you so much. Have a great
Thank you all for joining.